So today's topic is cloud as a platform. So first we need to know about what is mean by cloud. So cloud is a platform that provides infrastructure, development tools, and operation service to build and test and develop or deploy our application in a cloud. So these are the features that cloud is going to provide to user. So these are the cloud computing components, we can say characteristics, what models the cloud is going to be giving us to utilize, and what are the deployments models we have. So let's talk about the service models first. So we have three types of service that cloud will provides. So IaaS, infrastructure as a service. The IaaS is offers virtual computing resource like server, storage, and networkings, like Amazon Web Service, that easy to instance, and Google Component Compute Engine. These are the example for this IaaS infrastructure. Infrastructure as a service. Second one is PaaS, that means platform as a service. It provides a platform for developer to build application without managing and underlying infrastructures. So example, AWS Elastic. And third one is SaaS, software as a service. It delivers software application over the internet. So what are the three main components are IaaS, PaaS, and SaaS. So what IaaS provide is, it provides server storage and networking for our website, and PaaS is provides developer to build his application, and SaaS provides the internet without interruption. So what are the benefits of cloud is, so scalability. So as of now, I need 100 people are going to use my website, so it's okay. If the number is changed to 100 to 1000, so I need to be scale up with my website. So cloud provides that scalability facilities, cost efficiency, faster development. So what are the operations we perform on cloud? So cloud resource management, that means cloud resource scaling up. So that means by scalability. So I can scale up my website to down or high at any time. It demands upon the particular place. So monitoring and logging. So that means it cloud this component is going to track the resource uses and application health. Security operations, so include identity management, encryption, and compilation. So the authentication process, those things are handled by security operation. Disaster recovery and backups, so whenever I lost my data in any somewhere, so I can back up my data through cloud. So what is the importance of cloud? So cloud technologies ensures highly availability and reliability for users. So the cloud platform will help us to increase our scalability. So depending on our demands. So deployment pipelines. So what do you mean by, what is mean by pipeline is a set of automated process to build, test, and deploy application. That means we are going to deploying our entire website through pipelines, so we can host it on any cloud-based platform. So the pipeline will have two embodies, CI and CD. So CI means continuous integration. So continuous integration means the developers change frequently to share repositories. So at the time the testing will be done. So continuous deployment. The continuous deployment means whenever the testing is completed, then it will be going to deploying to the production side. So these are the 8 features that are split: 4 for continuous delivery, 4 for continuous integration. So what are the tools we need to use to deploying a project? So for using the version control system, that means keep tracking the code changes, and those things all are handled by Git or GitHub. So if I wanted to build an automation, I need Jenkins or GitLab, CI/CD pipelines, circular CIs. So if I need containerization, I need to use the Dockers. Orchestration is done by Kubernetes. So tools for deployments. So as I previously told that various tools support the deployment pipeline, including Jenkins and GitLabs. They also provide metrics and development success and failures. So what is the pipeline stages? So basically there are 7 pipeline stages. So first one is plan. So the first one is plan. So what are the requirements for the finalization, updations, new changes, architecture designs, task assignments, timeline finalization. These are all done in the plan. Second one is code development and source control. That the entire website's algorithm will be done by coders. So we call as developers. So build, compile code and resolve dependencies. Test or an automated test. That means the entire code will be tested by testers. So release, creating a production ready builds, deploying through any one of the cloud resource. We are going to deploy our entire websites. So monitor means we are observing any issues are occurring or not. So these all are handled in monitors. So this is the overall pipeline overview. So we have 7 categories. We divide into 7 types. So first one is a plan. So what are the plans we need to be handled to complete that particular project? Code, it is handled by the developers. Code and build. So they are continuously integration. That means they are going to change modifications whenever the tester given to the task to again them. So then we release and we deploy the entire project in any application. So then it will be hosted in our website. So we are going to monitor the websites we have any issues or not. So architecture. So what is the architecture to build a particular website? First, developers. So they are going to write the entire code for that websites. So these we are using Git to keep track the changes. So those who are changing the code and who are modifications, who done these things all are handled by the version control. So then we are going to use the Jenkins for automation. After completing the automation through Jenkins, we are going to use the Dockers as a containerization. So after containerization, we are going to deploy the entire project in Cloudera. So you can take it as Google Cloud as platform or AWS. So I go through AWS only mostly. Whenever we host our we deploy our entire project through AWS, then we can see what are the maintenance, what are the issues have any occurred or not. So this is the architecture all about testing and building the entire project. Testing clouds. So testing clouds means unit testing, verify individual components. So first we have divided the tasks into individual. So we are going to verify all the individual components first. Integration testing, ensure interaction between component work. Load testing, assess system performance under high demands. So these. Okay. So deployment. Now the process of delivering an application to the cloud environment for user. So it is called as deployment. So that means we are going to give user to access that particular website. So that is meant by deployment. So there are types of deployments we have. Rolling deployment, incrementally update server with new version. So whenever the new version will occur, so we need to ask the user to update the new version. So blue green development, use 2 environments, one active and one staging. Canary deployment, release to a small subset of user before full rollout. So in the middle of the way, we are going to deploy that entire project to user. So that means our project is not fully completed, but we are giving facilities to use our website to user. So case study, we will take one case study of migration to the microservices. Transaction form on monolithic application to the microservices. It is a one thing. Challenges, complexity. So breaking down tightly coupled components, data management, handling distributed database, performance, monitoring multiple services. So what are the steps? So decompose monolithic, identify and separate functionalities into services, implement API gateways, use tools like AWS API gateway to manage the API calls. So application programming interface we are going to utilize by the AWS. So containerization, mostly we are going to use the Dockers for the containerization. Deploy an architecture, that means Kubernetes we are going to use for this one. Monitor and use like Grafana for insights. Those are going to be utilized to use the monitors. So what are the benefits? So scalability and fast development cycle, fault isolation. These all are benefits for the using the clouds. So security consideration. Security is paramount in the motivation of cloud architecture. So mostly we are going to encrypt and secure access the control protect user information. Regular securities audit help identify and mitigate potential vulnerability. Done.